ऊपर से
डिस्कस
ऊपर से क्या बात कर रहा है यार? It's very
इधर आ रहा है लेकिन अभी ज्यादा रहता है ना। हाँ मतलब
यहाँ
पे समझ में आ जाएगा। घर पे जाके याद रख तब बात करना।
एंड व्हाट अबाउट ट्राइज?
tries we
वो
do tries
नहीं
all
आज वो नहीं करते हैं।
tries is easy.
हाँ ट्राइज इज इजी, ट्राइज बहुत अच्छा है।
मैं तो सब इजी लिंक लिस्ट स्टैक सब कुछ इजी क्यों पढ़ लो।
नहीं ऐसी बात
लेकिन घर पे जाके ना
यार ये मिक्सर ना बन गया बस।
वो ही रहता है।
वो तो होगा ही यार।
नोड और इसमें एजेस में थोड़ा सा कि फंक्शन कौन कौन से लिखने के
थोड़ा सा टाइम लगता है जब तुम उसको अलग प्रिंट कर पाओगे।
इसे रियलाइजेशन। हाँ वही तो।
तो प्योर प्रिंट होगा।
Okay. So breakfast search, we'll set start node to C start. So we set whatever is the start node as C start, and then we'll check the certain condition that okay the node is null, which means that there is nothing in there and blah blah blah, and then we'll do reset visited, which will reset everything to not visited, and then we'll say a node start node is equal to get node C start. So we'll get the start node and we'll get this node. Okay. Then we will say we'll print.
So you are doing this in recursively or?
I will no, this is not recursive.
Okay.
This is not the use of first line of one
Q
line.
create करेंगे।
I will set the start. Why
Q
we
create
need to do that?
Setting
Oh,
start
you
node.
want to start from there.
Yeah, start from. क्योंकि graph है, there is no start, there is no end, so we need to set that, and then we reset everything, and then we say get the start node, and I'll say print starting from blah blah
एक
blah.
फंक्शन
Got it.
ऑब्जेक्ट को
Okay.
पता क्यू स्टैक
Then, then we actually create a queue node, queue. So we'll say queue a node star queue nodes. So we'll create that queue, and then we will put queue dot push start.
But Ashish, one thing, like
Yes.
if we have a start node which has no outs, no edge, no
Yeah, then the breadth first search will just
Return the start.
return the start.
and there are nodes which are coming in towards him, but there is no outgoing. So how will
So this is undirected. So in breadth first search, people are pointing to me. This is directed. People are pointing to me. I'm not pointing to anybody, and I'm saying do a breadth first search.
for me? So there will
Yeah.
be no.
So if you are there, let's take the French example. I create a Facebook account. People added me as a Facebook friend, but I have not added to anybody.
Okay.
And if you call on me that get the friends of Ashish, I don't have any friends, it will return me null.
Okay.
That's the expected behavior. Okay. So we'll say we push that and we set start node dot set
Q dot push not. Q dot in Q.
in queue या push मतलब in C, yeah, it's the same thing, yeah, in queue. In STD, this is a standard template library, so there's a push which pushes.
Okay.
Okay, so dot set visited is equal to true. So we set that visited is equal to true.
Right. And then we will start the loop.
Then we will start the loop. So we'll check while not queue is empty, which means that while the queue is not empty, what we will do is we will get a node star node is equal to queue dot, I will say pop. In C++ it's different, but I'm just saying we pop the front. So we get the front, and then we'll check if not node dash is visited. If the node is actually not visited, then we will print visiting this node, whatever the node's ID is, and then we will set
It's visited.
visited is equal to true for this one, for that particular node. Okay, and then what we will do is vector of characters neighbors is equal to node arrow get neighbors. So we'll get all the neighbors for this particular node, and then we will write a for loop for integer I is equal to 0, I is less than neighbors dot size, and blah blah blah. We will say we will push, we will check the condition. We'll check the condition. If node is not visited, then push it in the queue.
Yes.
Right? And this will run, and when everything is done, we'll just break out of this.
Same code for DFS. Just
Same code for DFS. Instead of queue, you will do a stack. That's it.
That's why I was saying just break a common
Yes.
common search function and pass the queue and step also and use their function. One code.
Exactly. So, okay. Yes, easy enough. Yes. Okay. We'll first understand the Dijkstra's algorithm, and it will. I tried implementing the algorithm, but like there was a priority queue, and I'll get into the details later. But I was not able to understand the prior. I was not able to implement the priority queue part.
Is it there in that book?
Which book? No, it's not implemented anywhere.
Okay,
So
so do they ask or?
If they ask you a Dijkstra's algorithm implementation, that will be, I don't know, at least 20, 30 minutes. 20 minutes.
I think
minimum.
they should not ask.
They should not ask, but
because these are the theoretical. They are not going to test your.
If they are asking this kind of question, then the position is very dangerous. Don't join there.
SD और SD के लेवल में कुछ तो डिफरेंस रहेगा ना.
Even
SD तो नहीं पूछेंगे ये क्वेश्चन.
हैं?
SD तो नहीं पूछेंगे.
उससे पूछा नहीं था आशीष से.
Dijkstra's किसी से नहीं
उसने
पूछा था.
ग्राफ पूछा था,
ग्राफ
उसको
is
बता
different
रहा
thing भैया, ये चीज.
ठीक है, ये ग्राफ का ही पार्ट है. ग्राफ
ये कंप्लीट ये क्वेश्चन हमारे कोई एसडेट लीड को ले आई, उसको नहीं पता होगा किसी को. ये पीएम मैनेजर को
नहीं पता होता है. SD को पता.
नहीं, एसडी लीड को लेना या एसडी मैनेजर
को क्यों पता होगा यार? क्यों तुम परेशान कर रहे हो?
क्यों नहीं पता होना चाहिए?
क्यों
कोड करना
भैया? कोड रिव्यू करेंगे.
सड़ गया मैं तो प्लीज जाएगा नहीं कर.
भाई तो
नहीं भैया, एसडी लीड को पता नहीं होगा. नहीं, गलत कर बहुत नहीं, गलत कर.
कभी बातें करते हैं हम. नहीं पता होता.
वो बात ठीक है, कोई होंगे ऐसे.
उसी को भेजते हैं जिसे आती हैं सारी चीजें. किसी को नहीं भेजते.
नहीं यार.
नहीं भाई, ये
मुझे पता नहीं आती है.
मतलब
माइक्रोसॉफ्ट को भाई सब तोड़ना नहीं है, तोड़ना नहीं है.
कोई वो पूछते हैं तभी तो.
भाई साहब, आप स्वराज लाओ, पर आप कैमरा तो तोड़ रहे हो.
यार मैं
ये आम आदमी है ना, कैमरा तोड़ देते हैं बस.
कैमरा से इनका ज्यादा
और बाद में जब खुद कैमरे पे आते हैं ना, तो फिर कुछ और तरीके से बोलते हैं.
एक
आम आदमी वाले में बड़ी तक टेंशन में रखेंगे.
ये बीजेपी वाला आदमी है. ये बीजेपी
कांग्रेस ही
कांग्रेस बोल दो यार.
कांग्रेस बोल दो.
मैं बीएसपी का हूँ. मायावती.
कांग्रेस झाड़ू के बिना
नहीं, वास्तव में ये लोग मेरा जो टेंशन में रखेंगे कि क्या कर देंगे ये पता नहीं. पर
भैया,
वो स्कैंडल निकला है इनके.
जितना काम किया तुम बता दो, तुम्हारा कौन सा मतलब.
हाँ, आज
दो तीन स्कैंडल निकला है.
आज तक रिकॉर्ड इतना काम किसी ने नहीं किया.
सही बात है. रोज तुम्हारा गाड़ी साफ करेंगे.
okay. Let's see.
Let's see
Let's see.
this.
This is a graph,
Okay.
and this is. I'm not doing it as a. I'm just saying that
This is not a directed.
this is not a directed one. This
Unbreakable
is,
one.
I'm just doing it for the explaining purpose. So we are doing a Dijkstra's algorithm, and we are starting with 1, and then we are going to all the different places, and we are trying to find the minimum path from one to a different location. Yeah.
ABCD कर सकते हैं उसको.
यार इसमें मैंने उससे
अच्छा,
किया हुआ तो
ठीक है.
I will. I think this is. I actually understood it from the Wikipedia,
ठीक है.
and like I'm just explaining that example. So, but that is okay. I can change it to ABCD after.
नहीं ठीक है.
So the Dijkstra or Kruskal's algorithm are only for the minimum path,
Shortest path.
Shortest path. There is a question for the longest path.
No.
I will discuss after explaining this. So let's say we are starting with 0, right? With 1. We are starting with 1, right? So first in this, what we do is we actually make everything else infinite. Infinite is basically like
No.
I don't know what is there. this is basically 0 at this point, whatever you want to call it. So we are starting with 1. Okay, so next what we want to do is we actually will start with 1. So we will actually write 1 over here. And then we have two different things. One is visited and one is not visited. Visited. This list or whatever you want to call it. This list is empty, and then we unvisited. We will add all the things in unvisited. So right now 1, 2, 3, 4, 5, 6. So these are list of unvisited. We'll start with 1. From 1 to 1, if we actually go, there is 0. Right. From 1 to 2, if we can go 7, which is actually better than infinite. So we will write 7 over here, and we have reached it through 1. Okay. 1 to 3, can we go to 1 to 3? Yes, we can, and the distance is 9, which is better than infinite. So we will write 9. Okay. Then we will check 4. Can we go from 1 to 4? No. So we will write infinite.
Okay, directly we can go.
Yeah. We will see from 1 to 5. Can we go there? No. So we will write infinite. We don't know how to get there. And 1 to 6 is 14. And we have reached it through 1. Okay. So that is the 1. Because we have started with 1. We just go. Now we have to, this is the backtracking part. Now we actually have to, or the greedy algorithm, whatever you want to call it. So we'll see which one is the shortest amongst this. 7. So which means that from 1 to 2, if we go, that is the shortest or the cheapest one.
Right.
So the next step we will do is 2. We'll start with 2. Okay. 0, that is from 1. We'll just keep that. 2 to 2 is 7. We'll just keep 7 and 1. Okay. 2 to 3 is 10. Which means if I go through 2, I will have to spend 7 plus 10.
Yes.
Right? 17. Which is actually bigger than 9. So we will keep 9
only.
and 1.
Yes.
2 to 2 7 sorry.
2 to for reaching 2. For reaching 2, we started with 1.
Yes.
For reaching 2, like there is no other way, right? Like that.
Starting is still 1.
Your starting is still 1.
Still 1, okay.
Yeah, we are starting from 1. Okay, so we will go to 4. 2 to 4. Is there a place? Yes.
Yes.
And the distance would be 15
22.
plus 7, which is 22. We write 22.
1 and 2.
And we have reached it through 2.
Oh, we'll not write 1 and 2. Okay. That means
Yeah, that means 1 and 2.
Okay.
So for 22 we have reached to 2. 2 we have reached. 2 we have reached from 1.
Okay.
And 1 is, so we can go from here till here and then.
Okay.
Okay, 5. Can we reach
No.
2 to 5? No, it's still infinite. And 2 to 6? No, so 14 and 1.
That is little confusing. I mean, from 2 here on the left hand side, we are writing 1, 2 or this way, right?
Yeah.
2, and then under the 4 we are at in the bracket we are keeping
It's the
2.
same because you're going over there through 1 only.
Actually,
1 and 2, and it's a combined way.
एक बार शुरू से कर लीजिए
Okay, एक बार शुरू से कर दे.
लेकिन मतलब लिखा हुआ ही रहने दो ऐसे ही एक बार दोबारा स्कैन
Okay.
कर लो
I'll just, it's easy, it's easy. It's actually very simple. Let's just do it. So we start with 1. We have been told that we have to go from 1. We have to traverse from 1. So we have to traverse from 1. We'll take this. From 1, then we will make everything infinite because we don't know anything. So we are starting from 1.
Okay.
From 1 to 1 is 0. We have reached it through 1. Right?
So
We are still
not
over.
to write this 1 because we are starting from the right.
This side it is
already background.
This side, what we are taking is like which one is the current one from where we are going.
Right, so this bracket is need not to write for the 1.
चल ठीक है यार चल
Right, creating confusion. Okay.
1 to 2. 7, which is better than infinite. So we'll write 1 because we want to know that yes, we came from 1. 3 to if, because if there is another, if I don't write 1 over here, the next time 10 to 7, if I'm writing 3, I don't know if this 3 is through 7 or this 3 is through 9 or this 3 is from 17. Right? So that's why I'm writing 1 over here. Okay. 3, okay.
9.
1 to 3 is 9, which is better. And we have reached through 1. 1 to 4, there is a way, no. 1 to 5, there is no way. 1 to 6, there is 14, and we have gone from 1. Okay. Next, out of this, the smallest, so then we will actually add 1 in the visited and remove 1 from the unvisited. So 1 has been visited. Now we will check out of the unvisited which one is the smallest. 7 is the smallest. So which means that we will take 2. We'll take 2 in the visited column and then we will start with 2. So this is already 0.
So as we are trying to find the smallest path, from where to where?
From where to? From this is the entire graph. And then after that, like you create what in Dijkstra's algorithm, you actually create the entire thing because you have to do a backtracking part.
Okay, but here we are not finding particular node that we are going from here to here.
I don't remember the boost algorithm, the boost structure for that. But in boost, what you actually do is you actually create a graph, like we created graph. We create a graph which has all the list and stuff like that, and after that we say Dijkstra's algorithm, and then we pass a graph into it. So that will actually create a Dijkstra's